These are the solutions to yesterday's assignment of the numbers 3 and 4 off of the Ellipse worksheet. So taking a look, I have some of the information filled out. The idea here is, in order to write the equation of the ellipse, not only do we need to know like the direction, like where the direction of the major axis, if it is horizontal or vertical. We have the center written out here, and I'll explain how I'm coming up with the a and b value. So like a circle where we just need the center and the radius, because with an ellipse we don't have a constant radius, we need to write out what values a and b are for each problem. So first we have to count carefully for the center. Looking here at a, it looks like if I were to count over 4 and up 2, that would be right in the middle. We could still check this though, and this is what's going to help us determine A and B. If I counted over 3 to the right, I'm at the edge of the ellipse, so that's where I'm getting A is 3. Also, if I count over this way, so if we know the length of the major axis here, we just cut it in half to find A. B, I'm just counting up 1, it looks like, or down 1. So B is 1, and then A is 3, and then we can go ahead and write this out. Now the idea here is any ellipse, equation of an ellipse in HK form is going to be the sum of two fractions, and it will always equal a 1. In my numerator, first numerator will always be a quantity involving x, so we're going to have x minus h, so we get x minus 4 squared. And then the second numerator will be y minus k squared, so y minus 2 squared. Now because the major axis is horizontal, a squared is going to go first. A is 3, so a squared will give me 9. B squared is 1, so 1 squared, or b is 1, so 1 squared is 1. So we're getting x minus 4 squared over 9 plus the quantity y minus 2 squared over 1 is equal to 1. Now for b, I have the equation written out with the center a and b listed here, so you could just double check, see if you had that correct, and I will go over it. So here, if we count over 4 and then down 4, it looks like we're right at the center. And it has the same direction, the major axis has the same direction as part A. So if I were to count over to the right, it looks like I'm counting over 5. Notice it looks like it goes right to 9 right here. So A is going to be 5, and then B is 2. If I count up here, my minor axis, half of it, is going to be 2. So again, because our major axis is horizontal, I'll use a different color for that. Major axis right here is horizontal, with A being 5. We can, like the part A, we know a squared is going to go for our first denominator. So let's go over the center first. I'm going to have x minus h, so x minus 4 squared. But carefully look here, we have a negative 4 for k, so it's y minus a negative 4, which turns into y plus 4, that quantity squared. Again, because our major axis is horizontal, a equals 5 means a squared, which is 25, goes for our first denominator. B equals 2, so b squared is 4, goes for our second denominator. All right, I also have the equation written out for part C, so go ahead and double check that. Going over this, our center is at negative 3 up 2. If my major axis now is vertical, so if I started at the center and moved up, it looks like I'm counting up 3 units, so A is 3. I could also count down 3. B looks like it's going to be 2 units. And because our major axis is vertical, a squared, which will be 9, is our second denominator. So if you notice right here, a squared is 9. Again, x is going to go in the first numerator, so it's x minus h. X minus the negative 3 becomes x plus 3, that quantity squared. Next, I'm going to have y minus k, so y minus 2, that quantity squared. Since a equals 3, a squared equals 9 goes second. B squared, which would equal 4, goes first. All right, for number 4, I did mention that you can graph these. A did not graph too nicely, but I'm still going to talk about that. Also, not only did we have to write out the coordinates of the center, but the endpoints of both axes. I'm also going to write out the length of the minor or the major axis as well. So let's take a look at A. What I'm first going to do is group the x terms together. So we have 3x squared plus 6x, then plus y squared minus 8y. I'm going to move the 11 to the other side. So what I first want to do is factor out a 3 from the first two terms. leaving us with an x squared plus a 2x, and then half of 2 is 1, 1 squared is 1. There's nothing to factor out from the next two terms because this leading coefficient is 1, and that's a good thing. So I'm just going to write it in parentheses, y squared minus 8y, and then half of 8 is 4, so we're going to add a 16 here. But remember, on the other side, I didn't just add a 1, I added a 3, so we're going to have an 11 plus 3. And then over here, I did just add a 16 because there was nothing out in front. So then we have a 16. So now we're going to get 3 times the quantity x plus 1 squared plus the quantity y minus 4 squared. This is what's not going to work out so nice that we're used to. We're going to get 11 and 3 is 14. 14 and 16 will give us 30. We still want to divide next. We want this to be a 1, so I'm going to divide this by 30, this by 30, and that first term by 30. So now we get the quantity x plus 1 squared over 10. This is just a unique case. Remember how I said most of the time the two coefficients up here multiply to give us this number. This is just a unique case when they're not perfect squares. So then we're going to end up with plus y minus 4 squared over 30 equals 1. Our center is negative 1, 4. And then just to graph this, I'm going to write this out. A, or a squared, is 30, so we're just going to leave it as a is radical 30, and then b squared is 10, so b is going to equal square root of 10. Now if you wanted to, if you guys remember that one problem on the circles worksheet where we had the square root of 14, just type that into your calculator, and the square root of 30 is actually 5.477. And square root of 10 is 3.162. So just to go ahead and graph this to help us visualize this a little better, I'll show you what that could look like. Because we could even, if we've done these enough, we can actually determine the endpoints of vertices of each axis without graphing. There will be a little trick to figuring out what we have to add here. So I'm going to go ahead and just graph this one, plotting the center at negative 1, 4. And because a squared is our second denominator, our vertical axis, or major axis, is going to go vertical. So because I'm going to count up square root of 30, which is 5.477. So a little bit right here, and then count down a little bit right here. And then square root of 10, 3.162, I'm going to count to the right, just a little bit past 3, and then to the left. So right about there. We'll go ahead and draw our ellipse. Alright, so it looks a little bit like this. So we don't actually have to use the decimal forms now, but just to write out the vertex up here is going to be negative 1. And then really what we did was we started at the 4 and we added square root of 30. So we could write this as 4 plus square root of 30. And then down here we could say it's negative 1, and we took the 4 and we moved down square root of 30. So we could say 4 minus square root of 30. So really what's happening here is when our major axis is vertical, the x value is going to stay the same, and it's the y value that we're adding a onto and then subtracting a from. And then very similar off to the sides here, the 4 is going to stay the same. So what we're doing is we're taking this negative 1 and we're adding radical 10 to it, and it still has a height of 4. So we went negative 1 plus the square root of 10 this way, and then over here is going to be a negative 1 where we start out and we moved square root of 10 units over to the left, so 1 minus square root of 10, and then we have the 4 there. So that one was a little tricky if you weren't able to figure that out. Writing in the length of the major axis. So if from here to here is a square root of 30, the entire length of the major axis would be double that, so that's going to equal 2 radical 30 units. And then the length of our minor axis, even though I wasn't asking for this, let's just write this in. It's going to be, this is radical 10 units this way, radical 10 units this way, so it's going to equal 2 radical 10 units, just to go over all parts. Mainly because this one just had some radicals, it didn't work out to some nice numbers. Right, let's go ahead and take a look at B. Alright, so we first started with 16x squared plus 4y squared, 96x minus 8y plus 84. Like the last one, I'm going to go ahead and move my x terms together, and then my y terms together. And I hope as you're looking at this too, move the 84 to the other side, that you would realize we can identify this as an ellipse because on the same side we do have x squared and y squared, and we have two positive coefficients, but they're different values, so that's what makes it an ellipse and not a circle. Alright, so next I'm going to factor out 16 does go into 96, so I'm going to factor out the 16. We'll have an x squared, and it's actually 6. 16 times 6 is 96, so then we'll have a plus 6x. Half of 6 is 3 squared will give us 9. And then over here I'm going to factor out a 4. Be careful of this minus sign. So we're going to have a 4. And then we'll have a y squared minus a 2y, factoring a 4 out from the 8. Half of 2 is 1, 1 squared is 1. Now pause this for a second if you didn't already do this, but ask yourself, what exactly do we need to add to the other side? So over here, we didn't just add a 9, we added a 9 times 16, which is actually a 144. And then here I didn't just add a 1, I added a 1 times 4, so we're going to add a 4. So now out in front here, we still have the 16. This becomes an x plus 3 squared. And then we have a 4, and then in parentheses, a y minus 1 squared. Here we could just do 144 minus 84 is 60. 60 plus 4 will give us 64. Now we're back to seeing like the 16 times 4 gives us our 64. So this is what most of our examples look like. I'm going to go ahead and divide everything up here by 64. And we end up with the quantity x plus 3 squared over 4 plus the quantity y minus 1 squared over 16 equals 1. Our center here is negative 3, 1. A, again, is a squared is larger, so a squared is 16, which means a is 4. B squared is 4, which means b is 2. So we'll go ahead and graph this to help us write our vertices as well. So we have a center at negative 3, 1. Again, since our a squared, or larger denominator, was second, I'm going to count up 4, and then down 4, 2 to the right, and then 2 to the left to draw the ellipse. Alright, and then writing in our vertices here, at the very top, we have a negative 3, and kind of like what I just did for the last problem, when our major axis is vertical, the x value is going to stay the same, so we still go negative 3, but then we're taking this 1 and we're adding 4 to it, so 1 plus 4, but we could actually add that unlike the last one, but this is negative 3, 5. And then down here, we're still going to have a negative 3, and then it's going to be the 1 minus 4, which will give us negative 3. So we could still calculate each one maybe without even trying to graph this. For the vertices of the minor axis, our y value of 1 is going to stay the same, but we're taking this negative 3 and we're adding 2 to it, so negative 3 plus 2 will give us a negative 1, and then the 1 stays the same. Over here we're taking negative 3 and we're subtracting 2 from it, so we're going to get a negative 5 and then a positive 1. The length of our major axis, if it's just 4 units up, so that's going to give us 2 times 4, which is 8 units. And I'm going to go ahead and just write in the minor axis for all of these as well. Is going to be 2 times 2, which will give us 4. Right, now we just have one more. Take a look at. Starting with 4x squared plus 9y squared plus 24x plus 18y plus 9. Like the last two, we first want to get our x terms together, so 4x squared plus 24x, then our y's together, 9y squared plus 18y equals negative 9. All right, our first step again is we need to factor out that 4. So we're going to have a 4 and then an x squared plus 6x. To complete the square, half of 6 is 3. 3 squared, I'm going to be adding a 9. Then next, I want to factor out a 9 from the next two terms. So in doing so, I get a y squared plus a 2y. Half of 2 is 1. 1 squared is 1. Now I have to figure out what exactly we added here. So right here, I didn't just add a 9, I added a 9 times 4, so we added a 36. Next, I didn't just add a 1, I added a 1 times 9, so then we're going to add a 9. Writing this out now, this becomes 4. This factors into x plus 3 squared, and then 9. This factors into a y plus 1 squared. Over here, the 9's cancel, and we're just left with 36. Again, 4 and 9 multiplied together give us 36, as are most cases. So we're going to divide everything up here by 36. And we end up with the quantity x plus 3 squared over 9 plus the quantity y plus 1 squared over 4 equals 1. Our center is a negative 3, negative 1. A squared is the 9, which means A is 3, and because it's first, our ellipse is going to have a major axis that runs horizontally. B squared is 4, so B is 2. Going to graph this. Alright, so we have center at negative 3, negative 1 this time. Again, our major axis runs horizontally, so I'm going to count 3 over to the right, 3 over to the left. I'm going to count 2 up and then 2 down. Drawing our ellipse in there. To write our vertices, this one here is going to be, again, we can start, our major axis runs horizontally, so our y value is going to stay the same. I'm going to take this negative 3 and add 3 to it, so this becomes 0 and then negative 1. Over here, we're still going to have a negative 1. I'm going to take the negative 3 and subtract 3, so we get a negative 6, negative 1. Up here at the top, this is where our x value is going to stay the same, so it's still going to be negative 3, but I'm taking this negative 1 and adding 2, so we get a positive 1. And then here I'm going to take this, again, the negative 3 stays the same. I'm going to take the negative 1 and subtract 2, so then we get a negative 3, negative 3. Major axis has a length that's twice as long as 3, so it's 2 times 3, which gives us 6 units. And then our minor axis has a length that's 2 times 2. So again, going from the center here, that's 2 units, but if we were to go up, this entire length would be 4 units. And again, just to show you, major axis from here to here would be 3, and another 3 is what's giving us the 6 units that's down here. All right, so if you have any questions, please email me. I'm also giving you guys a quizzes for today. It will be a timed quiz. Actually, you could start it today. You still have all weekend, so the latest by Sunday at midnight that you need to complete it by. It will be timed, so make sure when you sit down, you're ready to take the entire quiz, about 17 problems. Each problem you're going to have a different time limit on. Most of them will be 60 seconds. Some have 5 minutes if it's any problems that you have to complete the square. Please make sure you have your notes handy with you. You're going to need to look back at the examples we did and the notes that you took. So I will be posting that, the link or the code to get to that today as well. So be on the lookout for it. Again, let me know if you have any questions.